Okay, so in this clip, we're gonna discuss the materials or content in section 6.1, which is the PMF, right? This is probability mass functions of a function of two discrete random variables. For example, if I have random variable x and y, and both of them are discrete random variables, all it means is the range of x and y are discrete set, right? It's not a continuous set. So the number of uh, entries in the range is finite. Okay. And then we have another random variable w, which is obtained by taking a functions of x and y. So g is some functions with two inputs. Right here, we're gonna input the random variable x, and another input is random variable y. So W is going to be another discrete random variable. The question is, what is the PMF of this random variable W? Okay. So to study about this, let's do an example. This is coming from problem 611, page 236 in the textbook. So let's say X and Y have some joy PMF. So the joy PMF is given by these expressions. Okay, so if you're looking at this, you see that the joy PMF is the probability, right? So the probability is non-zero when x is equal to -2, 0, or 2, and y is equal to -1 or 0 or 1. Okay, so if you look at this, there are three numbers here, there are three possible entries here. So in all, there's going to be uh, 9 cases. Okay, and each case, the probability is equal to this 1 over 14 absolute values of x plus y. Otherwise, the probability is equal to 0. It says find the PMF of a new random variable w, which is equal to x minus y. So the function is just simply taking the difference between x and y, right? Or x minus y. So how do we find the PMF of this random variable w? Okay. First, we have to find out what this really is. What is this probability mass functions, right? So the first thing we do is we're gonna tabulate this joy PMF. Okay. So tabulate means instead of writing it in this cryptic way, we're gonna expand and show all the cases. Okay. So remember x, there are three possible scenario, right? X equal to -2, 0, and 2. Y is -1, 0, and 1. Okay, so there are 9 cases in all, right? We're gonna find the probability of each one of this. So if we use these expressions that is given to us, when x equal to -2 and y is equal to -1, the probability is equal to 1 over 14 absolute value of x plus y. So x is -2, y is equal to -1. So if you add this, it's -3. You take absolute value, so it's 3. So the probability is 3 over 14 for this case. So we put it here. And we can do the same thing with other cases. For example, when x equal to 0, y equal to -1, again, we go back to these expressions, right? So x is 0, y is -1. Whatever inside the absolute value is -1 or 1, right? Multiply with 14, so we divided by 14, we get 1 over 14, right? And we can all doing the same step with different cases. So we fill out this 3 by 3 table. Okay. Once we get this, we have to make sure this is valid PMF. First, all the entries must be bigger than 0, right? And it has to be probability. That means it's between 0 and 1. Check all the numbers, that's okay. Okay. And another check is you sum everything in this table. It has to come down to 1, right? Because that's all the possible cases, right? The possible probability is 100% of 1, right? So if you sum this 3, 1, 1, 2, 2, 1, 1, 3, so that's 14 over 14. So it's equal to 1, right? So this is check, right? Okay. Now let's think about W. Okay, so I'm gonna draw another table over here. Okay, so you see that W is equal to x minus y, right? So when x equal to -2, y is equal to -1, Minus 2 minus minus 1, you get minus 1. So this is the values of w as a function of x and y. When x equal to 0, y equal to negative 1. So 0 minus minus 1, this is equal to 1. Right? So we are using this functions to obtain w. And you can do the same thing with all the other cases. So this is 3, negative 2, 0, 2, negative 3, negative 1, and then finally 1. Okay. Okay. So step number 2, we want to find the range of this random variable w. So the range is the set of all possible outcome of w. So you're looking at this, right? So what are the possible outcomes? Of course, that's going to be negative 3. There could be negative 2. There could be negative 1, right? Actually, it happened in two possible scenarios: 0, 1, 2, 3, right? So this is all the possible values of w. So this is what we call the range of w. Okay. Step number 3, we're gonna find the probability associated with each value or each entry. This is what we call PMF of w. Okay. So we're gonna draw up another table where this is gonna deal with w, right? So this is all the possible values of the outcome of w. And we want to find the probability in each case. So let's see what is the probability of w is equal to negative 3. Okay, so negative 3 happens over here. This is corresponding when x equal to negative 2, x equal to negative 2, y is equal to 1. If you go further, the probability of that case is 1 over 14. So that means the probability of w equal to negative 3 is 1 over 14. Okay, we can move on to negative 2, right? W is equal to negative 2 only happen here, and the probability is 2 over 14. Okay, so this is 2 over 14. Probability of W is equal to negative 1. Now this is happen in two occurrences, right? So this case and this case, right? So the first one is the probability is equal to 3 over 14. The other one is 1 over 14. So you add this to 3 over 14 plus 1 over 14. This is equal to 4 over 14. W equal to 0 is corresponding to this scenario. This is when the probability is equal to 0. Okay. And etc. Right? You figure all these entries out. And this is what we call PMF, right? So we know exactly what is the probability that associated with each outcome. For example, W is equal to 1, the probability is 4 over 14, right? Or negative 1 is 4 over 14, right? So most likely it's going to be either negative 1 or 1, right? Because this is a bigger numbers, right? When you compare with the other probability. W is equal to 0, this never going to happen because the probability is equal to 0. Okay. One thing that you can check is if you add all this probability, then it should equal to the total should equal to 1, right? So you can check, right? This is 1, 2, 4, so that's 7, 4 to 1 another 7, so you add, you get 14 over 14. Okay, so this is also check.